All right, so when you're dealing with redox reactions, you'll sometimes need to balance them, and well, a lot of them are going to involve reaction in acidic or basic solutions. So how do you balance these problems in acidic or basic solutions? So there's a couple steps you need to follow. In the first step, step number one here, you need to write your half reactions from the original equation. Here we're reacting chromium-3 hydroxide with sodium hypochlorite to form a chromate and chlorine gas. And this is all in basic solution. So first we want to take anything with, say, chromium and break that up into its own half reaction. So chromium, what it's doing is it is turning from CrOH into CrO4 2 minus. And then hypochlorite into chlorine gas. Okay, so these are our two half reactions. And step number two now, we need to balance these half reactions for non-oxygen and non-hydrogen elements. So as an example, chromium or chlorine. So you'll see chromium, there's one chromium on this side and one chromium on this side. This is balanced. But chlorine, we have one on this side, we have two on that side. So you'll need to put a 2 there. So we've now completed step number 2. We need to work on step number 3 now. Balance oxygen by adding waters. So count the number of oxygens on both sides of this top half reaction. We have 3 times 1. We have 3 oxygens on the left, and we have 4 oxygens on the right. So we need to add 1 oxygen on the left by adding 1 water, H2O. And we'll need to do this for the other half reaction as well. We have 2 oxygens on the left and 0 on the right, so we'll need to add 2 waters on the right. Step number 4, balance hydrogen by adding protons. So up here we have 2 plus 3 hydrogens. We have 5 hydrogens on the left and 0 on the right. We'll add 5 H pluses, protons. And on the bottom, we have 4 hydrogens on the right and none on the left, so we'll add 4 protons on the left. Step number 5, balance charges by adding electrons. So check the charges. You want to make sure that you have the same charge on both sides of each half reaction. So the overall charge on this top left half reaction is 0, and the overall charge on the right is 5 plus and 2 minus. It's 3 plus. So you need to add 3 electrons to the right side so that your new charge now is 0, just like on the left. On the bottom half reaction, the overall charge is currently 4 plus and 2 minus. It's plus 2. And on the right, it's 0. So you need to add 2 electrons to the left so that now your overall charge on the left is 0. Okay, number 6, combine the half reactions to balance the electrons. So let's see. So one of these half reactions is releasing electrons. So you can see that, let's see, CrOH, and there's 3 of them. So chromium-3 hydroxide. It is releasing electrons. It is being oxidized, this chromium, and it is a reducing agent. So if this releases 3 electrons, then just as many electrons need to be absorbed. Here we have 2 electrons. We need to make sure that we release as many as are absorbed. We need to have the lowest common multiple. Of 2 and 3, that's 6. We need to have 6 electrons on each side. So multiply this top reaction by 2 so that there's now 6 electrons being released. And multiply the bottom half reaction by 3 so that there's now 3 times 2, or 6 electrons being absorbed. Now combine the half reactions to balance those electrons. So let's see how many. I generally like to write electrons on the extreme ends because they will always cancel out. So how many electrons do we have here? 3 times 2. There's 6 electrons on the left. Then I like to balance either protons and waters, and then the other things. So how many waters do we have? 2 waters. How many protons? 3 times 4, we have 12 protons. And now we have 2 times that 1, so 2 chromium 3 hydroxides. And 3 times 2, or 6 hypochlorides. And then on the right we have let's see, 3 times 1, we have 3 chlorine gases. We have 2 times 1, we have 2 chromates. We have 3 times 2, we have 6 waters. And we have 2 times 5, we have 10 protons. And then finally, 2 times 3, we have 6 electrons. All right, so now step number 7, cancel particles on both sides. Cancel particles that are in the same amount on both sides, or if they're not in the same amount, at least remove the smaller number from both sides. So how many electrons do we have? We have 6 electrons on both sides. They cancel out. How many waters do we have? We have 2 waters on the left and 6 on the right, so remove 2 waters from both sides, so that now you have just 4 waters on the right. Protons, you have 12 protons on the left, you have 10 protons on the right, so remove 10 protons from both sides, so that now you have just 2 protons on the left. And you can't cancel any of those other compounds. They're only present on one side. Now, step number 8. If you're in acidic solution, stop. You're done. If you're in basic solution, like we are in this problem, then you need to add hydroxides to both sides to balance those H pluses. You see, there can't be any or many available protons in a basic solution. So instead, we neutralize them by adding hydroxides to form water. So how many hydroxides do you add to both sides? 2. So add 2 hydroxides to both sides. Now, when you combine 2 protons with 2 hydroxides, that will actually form 2 waters, HOH. And so now we need to cancel waters from both sides. We have 2 waters on the left and 4 on the right, so cancel out 2 from both sides, so that now you have 2 waters. All right, that is all. Thanks for watching, guys.